So 10D resistance, first of all you have to know the different circuit symbols. You should already really know these, but you have to recall what does the symbol for a resistor look like. If I were asked to draw a circuit, for example, that had a resistor in it, I'd have to remember that the symbol of a resistor was just a simple rectangle, and I'd have to add that to my circuit. The same as a variable resistor then. A variable resistor is a resistor with an arrow going through it. Thermistor is just a resistor again with like a tick, just a line going through it. And then the LDR, which stands for light dependent resistor, has the circle around it and then the two arrows coming in, which we know represents light coming in. Okay, just very briefly, what do each of these things do? So the resistor simply resists current. It slows down or impedes the flow of current, so makes it harder for current to flow at a fixed rate. So a fixed resistor, which is this one, has a fixed value of resistance and the current will be slowed down the same all the time. A variable resistor then exactly the same, except you can manually change the resistance of this component, which in a second we'll look at why would I ever need to do that or why is it useful. So you can slide a device and it changes the resistance of that component in your circuit. A thermistor is technically a thermal resistor, so the outside temperature in a room outside the circuit will change the resistance of that component. Okay, specifically for the GCSE, you only need to know the negative thermistor. So for example, if temperature increases outside, then the resistance drops. And if the resistance drops, that means that more current is going to flow through the circuit. Things like the AC, for example, the AC will have a thermistor and there'll be a temperature sensor in the room that if the temperature gets to a certain point, for example, it gets high, then the resistance will drop and it will allow current to flow and therefore the AC will switch on. So that's one example of how that might work. LDR, again, it's a light-dependent resistor, so it's exactly the same thing. Again, its resistance depends on light intensity this time. Same negative as well, we only need to worry about the negative component. So if the light intensity in the room, for example, goes up, gets brighter, then the resistance of the component drops, in which case, again, more current will flow through. Okay? So that's what each of them do. In terms of resistors, when you combine multiple resistors, so these are simple fixed resistors, if you put two resistors in series with resistance value R1, R2, they could be the same, they could be identical, they may not be, but if you add those resistors in series, then the resistance will increase. And how do I know what the total resistance is? All I need to do is add the individual resistances together. So if this was 5 ohms, and we should have said really that resistance is measured in ohms, which is omega, and the ohm is spelled like this, O-H-M. And so if you want to know the total resistance of any combination of series resistors, it could just be 2, so R1 plus R2. You could have 5 in series and you just add all 5 together, okay? Parallel resistors, on the other hand, if you add resistors in parallel, essentially you're just opening up more pathways for electrons to flow, so the total resistance decreases. So adding resistors in parallel decreases the total resistance, whereas in series, the total resistance will go up. You need to be able to actually add, in an exam, the total resistance in series, but you don't need to worry about the equation for resistors in parallel. Okay, so just this one in terms of actually answering questions. Now, Ohm's law is a very, very famous part of electricity. It came up with one of the equations that we're going to look at, but it is an experiment that you should be able to at least have a go at if you're doing the experiment for the core practical as well. It's very similar. If we had a circuit, for example, with a battery, and what I'm trying to do in this experiment is I want to change my voltage, I want to use a voltmeter here, I want to change my voltage, get different values of voltage, and then measure the current in the circuit through a fixed resistor. Now, because I have a battery here, when you use a battery in a circuit, it has a fixed voltage rating. So for example, it could be 10 volts, and you can't change that, there's nothing you can do about that. So 10 volt battery, my ammeter's in series as always, so my ammeter's there to measure the current in the circuit. My fixed resistor's in there. I've put my voltmeter around the resistor in parallel. As we know, you have to put voltmeters in parallel. This will tell me the voltage that this resistor is taking from the supply. But because this is a fixed supply, I need to get different values of V. So what I'd have to add to my circuit is a variable resistor in series with the circuit. If I add this variable resistor into the circuit, what I can do is I can change the resistance of this component itself, and because in series the voltage is shared between components, which we know, If I change the resistance of this component, then it will take a different share of the supply. So for example, if I want to start at a very low voltage across my fixed resistor, then I've put the resistance of the variable resistor as high as possible. Because the higher the resistance in series, the more of the supply that that component will take. That means this one's getting the least amount, and that's where I start on a low voltage. I'll then start dropping the resistance of the variable resistor, which means this will go down, which means this will start to take more of the share, because that share will offset, this will take less, therefore this will start taking more. I'll get my increasing values in V, and I'll keep measuring the current through the circuit I. Okay? If I draw a graph, I should be drawing voltage as my independent variable on the X, my current on the Y, and the graph that I'll receive for current through a fixed resistor with changing voltage will be a straight line. I is directly proportional to V. Okay? Same again, if I just swap my axes, I should be doing V on the X because it's my independent, but if I swap my axes, I get V and I still get a direct proportion. Now what's the point in doing them both differently? Why not just stick with this one? So if you come to here, the equation that we can create from Ohm's law experiment is V, the voltage, equals current times resistance. So what that means is V is directly proportional to I, and the constant of proportionality, the constant in this graph, is actually the resistance. Okay? So V equals IR. R is the constant of proportionality. R is the resistance of this fixed resistor. It's fixed, so it's constant. And that's what the gradient's showing. However, if you rearrange this equation for R equals, it's V divided by I. Okay? So R equals V divided by I. Now if I took the gradient of this graph, the gradient of a straight line is Y over X. That's I divided by V. It's not the same as V divided by I. So if I did the IV graph, straight line, then if I take the gradient of this, which is I divided by V, but I want to find the resistance R, I'd have to do 1 divided by it. Okay, so the gradient from this graph is 1 over the resistance. It's the inverse. But if I just simply switch my axes to V and I, then the gradient is the resistance. Because the gradient on this graph is V divided by I, which gives you R from the equation. Okay, so just bear in mind, most of the graphs you draw in electricity are called IV characteristic graphs. You need this for the next section. This is the IV characteristic graph through a fixed resistor. Okay, so we always do IV. But in this case of Ohm's law, just to make our lives easier and not have to invert the gradient, if we do V against I, then the gradient is the resistance. One last thing. We don't do this in the experiment. We don't actually use a variable resistor to get this change in voltage and measure a change in current, because what we can use, instead of having a variable resistor in the circuit, it's exactly the same, but this one has a variable supply. So you're always going to be given a power pack where you can actually select the increasing voltage yourself. In that case, there's no need for a variable resistor. If you have a fixed supply, you need a variable resistor. If you have a varying supply, then you don't need that variable resistor.